already? Okay, good. We're going to firstly talk about quiz 15. Okay. Um, so question 6. Salim, can you read for us, please?
Yes. Convert the polar coordinates 7 pi out of 6 to Cartesian coordinates with r greater than 0 and 0 less than or equal than theta less than or equal to pi.
Okay, very good. All right. Consider this one, right? This is the polar coordinates. So x is going to be our cosine theta. So that is negative, right? 7 squared root of 3 over 2. The what? Okay, so this is equals. What equals? 1 equals r sine theta equals negative 7 over 2. So therefore, the Cartesian coordinate is this one. Okay. 12. Mustafa, can you read for us, please?
Convert the Cartesian coordinates -4, 6 to polar coordinates with r is bigger than 0 and 0 is less than or equal to theta, where theta is less than or equal to 2 pi.
Very good. Thank you. Consider this one, right? So we got to know where it is located, right? Which quadrant it is in, right? So x is negative and y is a positive. So it is in the second quadrant, right? So the point in the quadrant 2. And we also know that tangent of theta is y over x, 6 over -4, that's negative 3 over 2. So because of this, we know that theta is going to be what? This is going to be some negative value, right? Negative angle, and plus pi. That's going to be goes to the second quadrant, right? So which is this one. So 2.1588. We need what? Theta between 0 to 2 pi. In addition, we also know r is square root of this one, so which is square root of 52, or is 2 square root of 13. So it's also good. All right. So hence the polar coordinate is this one, right? Have the radius, and you have the radius, and also you have the angle, right? Okay. So they are in what? They are in radians. They are in radians. Okay. Question 14. Nick, can you read first?
Yes. Write the complex number -1/2 minus 1/2 I in polar form.
Very good. All right. So for the complex number, we also got to know in the complex plane where it is located, right? -1/2, -1/2. It is in the third quadrant, right? So it is in the third quadrant. So we got to know in the polar form, we need what? We need the modulus and also the argument, right? So the modulus is pretty easy to find. R by definition equals square root of the summation of the Cartesian coordinates x squared plus y squared. Right? Here x is -1/2, y is -1/2. So that's square root 2 over 2. That's the modulus. And then let theta be the argument. Then theta, as we see, it is in the third quadrant. All right, it's in third quadrant. Now, then, and we will have what? Tangent theta is what? +1, right? +1. So therefore, theta is what? 5 pi over 4, right? 5 pi over 4. Now, here, some of us also said you can write as theta is negative 3 pi over 4. Okay, you can definitely do that. You can still do that. All right, so you can, this is the same angle, right? This is negative 3 pi over 4. Okay, you can do that as well. Okay, but we just need one. All right, we just need one. Okay, so either way is fine. All right, so for us, we can choose an angle between 0 to 2 pi. So 5 pi over 4, right? So therefore, the polar form is going to be the modulus and the bracket. Okay, some of us forgot the bracket. Okay, cosine theta plus I times sine theta. right? So that is the 14, right? That's 14. 18. Okay. Joshua, can you read first, please?
Write the complex number z equals 2.
To CIS, probably.
The CIS in pi over 3 equals 2 cos pi over 3 plus I sine pi over 3 from polar to rectangular.
Okay, very good. All right, so for this one, it's pretty easy, right? So we can just write this one down and multiply them, right? Distribution law, right? So distribution law, like 2 times this one times I times 2 times this. So cosine pi over 3 is 1/2. Sine pi over 3 is square root of 3 over 2. So we have 1 plus square root of 3 plus I, square root of 3I, right? So that is 18. Good. Okay. Some of us made some calculation errors, right? You've got to be very careful here. Okay. That is about the quiz. Okay. Any questions about the homework? 15 and 16.
I have a question with homework 15.
Okay.
13.
13. Okay, let's do that. Okay. Question 13. Oh. Right. Section 10.3, right? 10.3.
Yeah.
Okay. Yeah. Gotta go way back. Oh, okay. Okay. Just 1 second. Huh? 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 Yes, here it is. Okay, here we go. 10.3, 13, right? Okay, 13. Let's see, this one. Yes?
Yes.
Okay, very good. Let's see what do we have here. All right. Can you read it for us, please, Salim?
Yes. Do you want to read the whole following exercise? Okay.
Yep.
For the following exercise, convert the given Cartesian coordinates to polar coordinates with r greater than 0, 0 less than or equal than
Theta.
theta, and less than 2 pi. Remember to consider the quadrant in which the given point is located. Number 13, 3, -5.
Okay, very good. All right. This is actually a very similar equation as this one, right?
Mm.
Did you see as question 12, right? So we need to know the quadrant, and also we got to find the value of theta, right? After that, we can find the radius and the theta, correct? And then everything will be good. So we are going to do the same thing for this equation as well. So which quadrant is this in? X is positive, right? Y is negative, so it is in the fourth quadrant. Yes.
Yes.
Fourth quadrant. Then what is the tangent? Theta
Tangent.
equals -5 over 3. Yes?
Yes.
So theta, well, the inverse tangent of -5 over 3, this is going to be a value less than 0. Yes? In fourth quadrant. Okay, negative value. Okay, you can use a calculator to find it, right? You can use a calculator to find this one. So tangent inverse -5 over 3. And I found this negative. This one is -1.0304. All right, so you found this one. Tangent inverse is negative, this one. But what I need is an angle in the fourth quadrant, which is greater than 0, right? So that is to say, it must be the angle of what? Of this angle, right? Greater than greater than that. So this angle and this angle seems the summation of these two is what? Is 2 pi. Yes?
Yeah.
So we will have this angle to be what? 2 pi minus 2 pi minus 1.0304.
Oh, okay.
Yes? Did you see that?
Yeah.
Okay.
Yes.
So that is going to be our theta. And then for the r, you know, right?
Oh, yes. Yeah, I got
Right.
that. I'm only having trouble with the tangent.
Yeah,
That's the problem.
okay. So, well, for this one, we require that theta between 0 to 2 pi. So you need to find the angle from the positive real x-axis, right? Starting from here and ending at a terminal ray, which goes through the point, right? So that's going to be
Do
that
we
angle.
do we add them or subtract them?
Well, you got to be very careful, right? So if this one is going this direction, if it is negative, right, it is going this direction,
Yeah.
correct? Then
But I did is negative 1.03 plus 2 pi. That's
yeah,
what I did.
yeah, that would be correct. But it's the same,
Okay.
right? It is the same
Okay.
thing, right? So it is the same thing, right? So you plus 2 pi,
Oh, yeah,
then
okay.
you
I
go
got it.
back here and then take a full rotation, right? So that's the same thing. All right, very good. Any other questions on section 10.3? Then let's see, how about 10.5?
I had questions on 41 and 43.
41, 43? Okay, did we cover that or not?
We did not. That was
not.
kind of why.
Okay, all right, so let's do that, all right? For we will firstly cover something in the we didn't finish this section yet, okay? But I just put everything there.
That's fine.
Okay, let's just do that one after 41 and 43. Let's see what is that. What is that?
That's
31,
over there.
42.
That was over the root.
This 10.5, right? 10.5.
Yeah.
We're talking about 10.5.
It was evaluate each root. Evaluate
Yeah.
the cube root of z.
Yeah, that one we didn't cover that. Okay,
Mhm.
so here, right, 41, 43, right?
Mhm.
Okay, so we will talk about that in today's lecture, and then I believe you will understand.
Yeah.
How to do that. Okay.
That's what I figured.
Okay. All right. So in last class we talked about. All right, let's start. In last class we talked about the polar form of complex numbers, a plus bi, right? So we have the so-called modulus and argument. Then we move on to convert a complex number into the polar form, right? How to find the polar form of a complex number, and then how to convert a polar form to a rectangular form, right? Like what we did here in this example. Then we talked about products of complex numbers in polar form. So why we want to use polar form? Because in many cases, especially about the powers, the products, the division, and so on, it brings a lot of convenience in calculating this, all right, in all these calculations. So now the first theorem we introduce is about products, right? Z1, Z2, they're in polar form, and their product is simply what? Product of their moduli, right? Their moduli. And then adding summation of their arguments, right? And then you got the product. Now we proved this one given here, right? We proved it here. Now, this one, we demonstrate that this is an example, given Z1, Z2, and how to find the product of these two, right? So as we know, you can do the product of the modulus, right? Moduli 4 times 2 times cosine of what? The summation of their arguments, 80 plus 145, right? 145 degrees. And then you got that. And finally, you got this one. Good. That's how, right? That's pretty simple. Now, then let's consider the quotient of complex numbers. All right, the quotient is also pretty straightforward. All right, so Z1 over Z2 equals what? The modulo becomes their ratio, and the argument became their difference, right? Difference. Now remember, that's theta 1 minus theta 2, right? Theta Z1 is on the top, Z2 is on the bottom, right? So it's theta 1 minus theta 2. Okay. Now the proof is similar to the for the product. We are going to skip the proof. All right, but just know how to do that. All right, so this is pretty simple. All right, this one gives the ratio. Ratio Z1 over Z2 equals R1 over R2 in the brackets cosine theta 1 minus theta 2 plus I sine theta 1 minus theta 2. Okay. The moduli are divided, the arguments are subtracted, right? Are subtracted. Very, very straightforward. Okay, so now let's consider an example about this theorem and see if you can solve this one using this theorem. All right, so let's consider this example. Zhongxu, can you read for us, please?
Find the quotient Z1 over Z2 where Z1 equals 2 cosine 2 13 degrees plus I sine 2 13 degrees. Z2 equals 4 cosine 33 degrees plus I sine 33 degrees.
Very good. All right, very good. Can we do this? All right, please go ahead and see if you can find this. Okay. All right. So let's see how can we do this, right? In order to find the ratio, we take we divide 2 by 4, right? To the first radius by the first modulus by the second, 2 over 4, right? Now, because the argument is take their difference, right? The first is 13 degrees, second is 33 degrees, so their difference is 180 degrees. Now, 180 is definitely a special angle, so cosine 180 is -1, sine 180 is 0, so we can see that this is simply -1/2, right? It's simply 1/2, -1/2. Okay, so very, very easy, right? So by using this. Okay. Now, finally, let's consider this theorem, so-called De Moivre's theorem. De Moivre's theorem and De Moivre. How do you pronounce this one?
See Moivres.
De Moivre's.
I think,
right?
I don't know.
Okay, let's say that. All right, De Moivre's. I like that. Okay, I tried to search Google about this pronunciation, but I didn't find it. They're just about the Moivre, this mathematician, right? So on Wikipedia, I found that. All right, so but didn't find the pronunciation for this one. All right, the Moivres, right? The Moivres, all right, the Moivres. So z equals r cosine theta plus I sine theta is a complex number, as in the polar form, right? Then what? Raised to the power n, raised to the power n is what? R to the power n cosine n theta I times the sine. Okay, there's a bracket here. Okay, I times the sine n theta, where n is a positive integer. Okay, so now this one is you can use mathematical induction to prove this one. Okay, so it should be pretty easy, right? So z is definitely r cosine 1 times theta plus sine I times sine 1 times theta, right? So this is definitely true. Now, if z n minus 1, right? If z n minus 1 is r to the power n plus 1, n minus 1 cosine of n minus 1 theta plus I sine of n minus 1 theta. If this is true, right? If z to the power n minus 1 equals this one, then z to the power n equals what? Z times z n minus 1, right? So that is going to be, now z equals this one. The modulus is r, and z to the power n minus 1 is this one. So the modulus is r to the power n minus 1. So it is r times r n minus 1. Yes. And in the bracket is a summation by the product, right? This is a product of these two. So it's going to be the summation of their arguments. This is theta, this is n minus 1 theta. So it became cosine of n theta plus n minus 1 theta, right? And plus I sine of theta plus n minus 1 theta. Okay, so which equals what? R to the power n in the bracket cosine of this one theta plus n minus 1 theta is n theta, right? N theta plus I times the sine of n theta. Okay, so bingo, right? Got it. Okay, so that is how, right? Z to the power n is r to the power n cosine n theta plus I times sine n theta. Okay, so that is what we need, right? De Moivre's theorem. So basically what? You just take the nth power of r, right? Raise r to the power n, and what? Multiply theta by n, right? Multiply the argument by n, right? So that is going to be the power of this complex number in polar form, right? In polar form. That makes sense? Okay. All right. So this is a simple proof of this theorem. Now let's consider example here. All right. So consider this example. Arinda, can you read the first, please? Arinda. Okay, Garrett. Can you read the first, please?
Evaluate the expression in parentheses 1 plus I to the 5th power using the Moivre's theorem.
Okay, very good. All right, so how can we do this? Now, in order to use the Moivre's theorem, this z should be in what? Should be in polar form. Yes, we got to find the polar form, find the modulus, find the argument. Yes, and then you do whatever you need, right? So just use the theorem. So now, do we have the polar form or not for this one? It's 1 plus I. Is this in polar form? No, right? It's not in polar form, right? So we got to find the polar form, right? So let z equals 1 plus I, right? Then its modulus is what? Equals square root of 1 square plus 1 square, right? The real part and the imaginary part, they are both 1, or z. So it is square root of 2, right? Or is square root of 2, and theta, tangent theta equals 1, right? And it's in the first quadrant, right? And theta is in quadrant 1. Right? We have theta equals what? Inverse tangent of 1. Right? So it equals what? Pi over 4. Good. It equals pi over 4. Okay, theta equals inverse tangent of 1 is pi over 4. So what do we have? Hence z is equals what? 1 plus I equals square root of 2 in the parentheses cosine pi over 4 plus I sine pi over 4. This is in polar form, right? This is already in polar form. So now everything becomes easy, right? So hence by the Moivre theorem, we have what? We have, okay, 1 plus I to the power 5 equals, all right, square root of 2 to the power 5th, right? To the power 5th times what? Cosine of 5 times pi over 4 plus I sine 5 times pi over 4. Right? Which equals what? So what is square root of 2 raised to the power 5? Is that 4 square root of 2? Okay, equals 4 square root of 2. All right, 2 to the power 5 over 2. Right, so that is 2.5. Right, 4 square root of 2 in the bracket. So what is cosine 5 pi over 4? 5 pi over 4 is what? Cosine. Let's see in.
Would that be negative square root of 2 over 2?
Very good. All right, by the unit of circle, we know that the cosine is in the third quadrant, right? It's negative square root of 2 plus. Then how about sine 5 pi over 4?
Same.
The same, right? So plus I times this one is negative square root of 2 over 2 times I. Yes? All right, so now this one equals what? This one equals, all right, we can simplify this one again. All right, 4 square root of 2 times negative square root of 2 over 2. Square root of 2 times square root of 2, that is 2. 2 and 2 cancel out. That is negative 4. All right, and similarly, that's negative 4i. So that is the answer. Negative 4 minus 4i. Okay, negative 4 minus 4i. Good. Okay, so that is how we use the Moivre's theorem. Now, one key step is to have this complex number in polar form, right? got to find the polar form first. And then we can use de Moivre's theorem, right? So because the de Moivre theorem is based on the polar form of a complex number. So if it is not in polar form, then you got to find its polar form, right? Like what we did before. Okay, and then everything will be easy. Okay, all right. So this is this example. Okay, so it's de Moivre's theorem. Now a second part of this de Moivre's theorem is the roots of complex numbers. Okay, so if z equals r, okay, again I forgot this parenthesis here. Okay, is a complex number, then the nth root of z, okay, equals what? Oh, sorry. Equals this one. Okay, so now you have to be careful. There are n root. Okay, there are n different roots, right? N different roots. All right, for the nth root of a complex number, there are n different roots. Now these n different roots are the ones given here. Okay, so this radius or this modulus is taking the nth root, right? It's a positive number. I take the nth root. That's simple, right? But the argument, right? Consider the argument. Argument is taking the form of theta is the argument of z. Now theta divided by n plus, right, 2k pi over n. All right, where k can be what? 0, 1, 2, da da da, n minus 1. Okay, so this, for each k, it corresponds to a root. When k equals 0 is simply theta over n, right? When theta equals 1, it's going to be a different root. I said equal to another different one because the argument is different, right? So on and so on. So there are in total n different roots, okay, or n different roots. Okay, basically you got to find all of them, or just express them in this way. Okay, so all right, so that is the second part of the Moivre's theorem. It's to find the root of a complex number, the nth root of a complex number. Make sense? Okay, now let's consider example here. If the cube root of this angle of this complex number of this in polar form, right? So can you find this one? This is already in polar form. I believe it's easier, right? So solution. Okay, so the cube root, we are trying to find a z 1/3, right? 1/3, where n equals 3. N equals 3. So this one equals, all right, so 8 to the power 1/3, right? So that is the cube root of 8. And inside the argument became cosine of, all right, 2 pi over 3 got to divide by what? By n, right? Divide by 3. Okay, and but that's not enough, right? And plus what? 2k pi over n, which is 3, plus I times the sine, right? 2 pi over 3 plus 2k pi over 3. Where, well, you can just write it one more time. 1/3, that's going to be 2. This is going to be 2, and the bracket, cosine of this one is 2 pi over 9 plus 2k pi over 3 plus I times the sine of 2 pi over 9 plus 2k pi over 3. Okay. Where k equals 0, 1, 2. Do we have another one?
N minus 1.
N minus 1, that is already 2, right? So 0, 1, 2, there are 3 of them, right? 3 different roots, right? 3 different roots. So they are given here. So now if you want to, all right, so root 1 or 1 equals what? 2 cosine of 2 pi over 9 plus I times the sine 2 pi over 9. Right, this is root 1 or 2 equals, when k equals 1, that's going to be 2 cosine of what? K equals 1, 2 pi over 3. That's going to be 6 pi over 9. That's going to be 8 pi over 9. Cosine of 8 pi over 9 plus I sine 8 pi over 9. Right, that's R2, right? So when k equals 1, you just plug in and do that. And when k equals 3, now you can find R3, right? Equals when k equals 2. Okay, so you can find that. Okay, so you can find these are 3 different values.
I have a question.
Go ahead.
What decides k? How did you get k 0, 1, 2?
Very good. All right, so here is the theorem, right? The theorem tells us that the nth root of z is given by this formula, where what? N is a positive integer, so that is, for our example, that is cube root, right? We are trying to find the cube root, so n is 3. Make sense? Now, what is k? And k is 0, 1, 2 till n minus 1, correct? Now, for our example, n is 3, so k is going to be from 0, 1, 3 minus 1 is 2. Make sense? We're
so
just
confused. I don't know why.
we yeah, this is the first time we come up with this theorem, so it can be confusing, but it makes complete sense. All right, as you can see this, we have k can be 0, 1, 2, n minus 1. Okay, so this is good. Why it is good is because if you take the nth power to the power n, right? You will get z, you will just get r times what? The same thing, right? Let me just do this one. You take the nth power of this one times n, right? Nth power of modulus times the argument times n, right? So it's going to be the cosine of times n, so theta plus 2k pi. Yeah, right? You multiply by n, and plus I times the sine theta plus 2k pi. Right? So you can see that cosine theta plus 2k pi is the same thing as cosine theta, which equals, now this one is r, this one is the same thing as cosine theta plus I sine of theta, which equals z. Right, which equals z. So in other words, they are indeed the nth root, because if you take the nth power of this root, you got the itself. So therefore, each of them is a root. Correct? Okay, so for k equal to 0, 1, 2, 0, n minus 1, they are all the root.
So is k only 0, 1, 2, and n minus 1, or is it like 0, 1, 2, 3, 4?
Yeah, you can
Like
take.
for the example that we did, for example.
Right, right. That's a very, very good question. You can also take k equals n plus 1, n plus 2, da da da. That is going to be what? Just add another 2k pi here, right? If you, because and cancel out, right? It's just added 2 pi. You're just, if your k equal to n plus 1, n plus 2, right? Then your first value is going to be 2n pi over n. Yes?
Mhm.
Now, and then cancel out, that's just a 2 pi. It's simply the cosine
Okay.
of theta over n plus 2 pi. Now, but this one is the same thing as when k equal to 0, correct?
Mhm.
When k equal to 0 is theta over n, right? So you definitely can take these lines, but it doesn't make a difference.
Okay.
Does that make sense? Okay, so we just choose the n most simpler one, right? The simpler n ones. So you can just take a k is 0 from n minus 1. That works. Okay, that will give us all the roots. If you're taking, say, k can be from n plus 1, n plus 2 till 2n minus 1, you just got the same. You just get the same set of the roots because they are what? Periodic. These are periodic functions. Does that make sense? Okay, so you don't want to do that, all right? Because they are periodic. Okay, you just need what? K equal to 0 to 1 over to n minus 1. That's enough. Okay. Very good question. I like that question. All right, this is what? Critical thinking, right? This is very good. All right, we cannot just accept this. We got to question this, why this is true. Right, that's in many ways a very good way about learning. Okay, it's cool. Very good. Thank you, myself. Okay, so k is 0, 1, 2 to n minus 1. All right. So the reason why we just choose from 0 to n minus 1 is because it can be viewed as the simplest one, right? And you can definitely take another set of values like n till 2n minus 1 or 2n to 3n minus 1, 4n to 5n minus 1, and any these set of values, it will give exactly the same result because they are periodic. Okay, so we can just, because we only need the roots, so we just take one side of them. And it's better just to take from 0 to n minus 1 because it's simpler. Okay. Very good. All right, so now this is the Moivre's theorem. Is about the power of a complex number in polar form, right? So we can find the power of a root of a complex number and also the nth root of a complex number, right? So these are the Moivre's theorem. Okay. Now, again, let's now do this one, right? So now I think it's pretty easy to calculate this one for now, right? So for instance, 41, all right? Evaluate the cube root of z when z equals 27 of this one. So this z is going to be what? It's already in 27 is the same as what? Cosine of 240 degrees plus I sine 240 degrees, right? So the cube root is z 1/3 equals 27 cube root times cosine 240 degrees over 3 plus what? 360, right? 2k pi, right? 2k pi, that's going to be 2k pi. 2 pi is 360, so it's k times 360 degrees. Because we're not using degrees, right? We're not using degrees. So k times 360 degrees over n is 3 plus what? I times the sine. The same thing, right? 240 degrees over 3 plus k times 360 degrees over 3. Okay, so now you can write this one as what? Equals, here is going to be cube root of 27 is 3. Inside this one, you can simplify a little bit. That's going to be what? Cosine of 80 degrees, right? Plus 3 is 120k, right? 120 degrees times k. And plus I cosine, I sine. 80 degrees plus 120 degree times k. Where k equals what?
0, 1, 2, or 3. 0, 1, 2.
0, 1, or 2. Yeah. Okay, because what? Here we are trying to find cube root where n is 3, right? So it's from 0, 1, 2. So there are 3 different values. Okay, that's how we do this.
I have a question.
Go ahead.
Where did we get the 1/3 power of 1/3?
It's a cube root. It's asking for a cube root. Now, cube root in English means what? Means to the power 1/3. Okay.
Oh, okay.
So cube root of z equals z 1/3. It's the same thing. It's like the square root of z equals what? Z raised to the power 1/2. It's the same thing. Make sense?
Oh, okay. Yeah,
Right.
yeah. I get confused.
Okay, good. All right, very good. All right. Now I believe 43, you can do 43, Nick, right? So
Yeah.
same thing. Okay. Any other questions?
I have one more question.
Sure.
About, so does the cube root, like let's say 42, it says square root. Does that mean k has only 2, or does not like correlate? Does not affect k values?
Oh, if you're trying to find a square root, right?
Does that mean if it says square root, does that mean it's only 0 and 1, or does
0
not
and 1.
affect it?
Yes, 0 and 1.
It's 0 and 1. Oh, okay,
yes,
okay.
yes, because n, if for square root, n equals 2, right?
Okay. Yeah.
N equals 2, so k equals 0 and 1, right? Because n is 2, so 2 minus 1 is 1. So from 0 to 1.
Okay.
Now there
And
are only
the higher the root goes, the more k values that we can.
Oh, yeah,
okay,
oh, yeah.
that makes more sense. That makes a little more sense.
Okay, cool. All right. Because you see that we have nth roots, right? We have n roots, right? You have 3 cube roots. You have 2 square root. You have what? 4 fourth root. Right? In order to have 4 fourth root, you have to start with what? 0, 1, 2, and 3. They're all 4, right? So you're going 5. That's 0, 1, 2, 3, 4. So very good. Okay. Now let's consider this one. Okay. Now let's consider the final section of this semester. All right. So section 4.5, vectors and applications. Okay. Now, what is a vector? All right. A vector is a specific quantity drawn as a line segment with an arrow's head at one end. Okay. That is a line segment arrowhead is at one end. Okay, like what? This is a point P, and this is a point Q, and what? Have an arrowhead. Okay, PQ. That is a vector. It is a directed line segment, right, with the direction. It has the initial point at where it begins. Say here P is the initial point, and a terminal point at where it ends. So Q, right? So PQ. A vector is defined by its magnitude or the length of the line segment. That is the distance. It's going to be always positive. Okay, the length of the line segments and its direction. The direction, because what? There's the arrowhead, it's a directed line segment, right? Indicated by an arrowhead at the terminal point. It's from point P to point Q, right? Thus, a vector is a directed line segment. Okay. Now there are several notations. Okay, so one is the lowercase boldface type with or without an arrow on the top, such as U or U head, U arrow, right? Arrow overhead. Okay, so this is the first. You've got to use a boldface, right? Boldface. You can notation and you can denote a vector in this way. Lowercase letter, but boldface. Q is a PQ arrow. There's an arrow on the top. Okay, from P to Q, right? P is the initial point, Q is the terminal point. Okay, now 3. If initial point is 0, 0, is the origin, right? Is the origin. And the terminal point is at AB. Then it can be represented as what? As this one. Okay, so these are several notations. Right? AB. Make sense for the vector? Good. Okay. A position vector has initial point as 0, 0, and is defined by its terminal point at AB. Position vector of a vector PQ with this one is going to be this one. So there is a definition here. The position vector. The position vector is always have an initial point at point 0, 0. Okay, and is identified by this one. So basically, that's going to be the position vector of a vector with 2 points, right? With the initial x1, y1, ending terminal point x2, x2. That's going to be what? X2 minus x1, y2 minus y1. That's going to be the position vector of this vector PQ. Right? Okay, so this is what we mean by a vector. Okay, now let's consider this example. Okay, so Natalie, can you read it for us, please?
Yes. Consider the vector whose initial point is P 2, 3 and terminal point is Q 6, 4. Find the position vector.
Okay, very good. Thank you, Natalie. That's very good. Okay, now let's consider this one. We want to find the position vector of this vector PQ. So now let me just sketch the in x, y coordinate. Here's x, here's y. So I have, say this is a 3, and this is 3, this is 6, negative 3, negative 6. All right, so P 2, 3, that's going to be somewhere here. This is going to be our P, right? 2, 3, and Q is 6, 4. So 6 is here, 4 is somewhere here, right? This is Q. Okay, so the vector from P to Q is basically what? This one. Yes, it's basically this one. That's P initial point and terminal point, PQ. But we want to find the position vector of PQ. Okay, now how to find the position vector of the PQ? Now, as we can see, by definition, the position vector has the initial point at 0, and is identified by the terminal point AB, and the position vector of this one is given by x2 minus x1, y2 minus y1. All right. X2, y2 is the coordinate of the terminal point. X1 and y1 is the coordinate of the initial point, right? So basically it's the terminal minus the initial, right? Terminal minus initial. So what is the terminal for this one? Q. Initial is P. So Hans solution, right? The position vector of the vector PQ is what? By definition, initial 6 minus 2, 4 minus 3. Right, x2 minus x1, y2 minus y1. This one equals what? 4 and 3. 4 and 1. 4, 1. Now this is a vector by definition, we know, right? This is a vector with initial point at point 0. Yes. So point of the origin for 1 is a terminal point. So it is somewhere here. So this vector is actually this vector. The initial point is at point 0, 0, and the ending point is at point 4, 1, right? And by notation, we know that this is a position vector, and it can be represented as in the two, this thing, what? Not bracket, but something, right? So a triangle bracket, and I don't know how to pronounce this, but something, right? Here we have this. Okay, does that make sense? Okay, cool. All right, this is how to find a position vector. All right, position vector is, all right, terminal minus what? The initial, right, by what? The x2 minus x1, y2 minus y1, and that's going to be the position vector. All right, so I just draw a sketch of these two, so you know that the direction, as you can see, the direction of these two vectors are the same. Yes, they are pointing to the same direction, and also their lengths, or in other way, their what magnitude is exactly the same. Correct? It's exactly the same. So that's a position vector. Now consider this example. Okay, so let's start. Can you read for us, please?
Find the position vector of the vector B, whose initial point is at -3, 2, and terminal point is at 4, 5, then graph both vectors in the same plane.
Very good. All right, so consider this one. All right, solution. The position vector is what? Terminal 4, 5, so 4 minus what? -3. Yes? And 5 minus 2, which equals 4 minus -3, 4 plus 3, it's 7. And 5 minus 2, that is what? 3. Yes, that's a 7, 3. Okay, so that's the position vector of this vector v. Okay, now let's graph these two. Here's x, here's y. Okay, now the initial point is negative 3, 2. So say this is 2, this is 4, negative 2, negative 4, 2, 4, 6, 2, 4, 6, negative 2, negative 4, negative 6, negative 2, negative 4, negative 6, right? So now this is the plane, and then we want to locate the first initial point, negative 3, 2. So negative 3, 2, so somewhere here. That's the initial point. Terminal point is 4, 5. 4, 5 somewhere here, so maybe here. All right, so this is the vector, what? Like this one, right? Pointing in this direction. Okay, so this is the vector v, whose initial point is at negative 3, 2, and terminal point is at 4, 5. Yes. Now let's consider the position vector. Right, position vector is denoted in this way, whose what? Initial point is at point the origin. That's our initial point, right? But the end point is at point 7, 3. So 7 somewhere here, 3 is somewhere here. So should be somewhere here like this, right? Somewhere here. So now connecting the origin to that point, 7, 3. Okay, so something like this. Did you see this? Now you can also see this by comparing these two vectors. You see they are in the same direction, right? And also they are of the same length. Okay, so they are the same vector actually. Okay, the length, the magnitude, and the direction are the same. Okay, it's a directed line segments, right? All right, so this is this example. Good. Okay. Now, magnitude and the direction. Right? Given a position vector AB, the magnitude is, all right, like the modulus of a complex number, right? So square root of a squared plus b squared, denoted by the magnitude, right? Absolute value, or the absolute value of v, right? So the direction is found by either by this one or pi plus this, okay, depending on the quadrant of the point lies in. Okay, so you can either use tangent negative pi, inverse tangent b over a, or pi plus tangent. Okay, let me just give an example. Now, for instance, if it is somewhere here, or somewhere here, right? This is theta 1. Now this is theta 2, right? So this direction can be easily found. This is from what? Negative pi over 2 to pi over 2. Negative pi over 2 to pi over 2, right? So it can be easily found. Inverse tangent b over a, right? So you can find that. Now, if it is instead in the third or the fourth one, okay? So, for instance, this one, this angle, right? This angle is going to be what? It's this one plus pi, right? So as you can see, it's the opposite direction of an angle of theta 1. Right, so and this is theta 3. Well, better to say this is theta 4. Right, this is theta 1. Okay, and this is theta 2. Something like theta 3 and quotient 3, right? Quotient 3. Okay, so these ones for these two, you would have to use what, pi plus inverse tangent. Okay, so that is going to be either in quotient 2 or quotient 3. Okay, so depending on the coordinate where the terminal point lies in. All right, so that is the direction is found by the angle theta. Right, it is from negative pi over 2 to pi over 2 or pi over 2 to 3 pi over 2. Okay, by using these ones. Now, of course, you can also use other points, other ways, but this one will you only need a direction, right? So this will serve the work, serve the job. Okay. Now let's consider this example. Mustafa, can you read for us, please?
Find the magnitude and direction of the vector with initial point P is -8, 1 and terminal point Q, which is -2, -5, and draw the vector.
Okay, very good. All right, so let's consider this one. Solution. By definition, the position vector is what? Vector of PQ is that's going to be -2 terminal point minus what? -8 and -5 minus 1, which equals -2 plus 8, that is 6. -5 minus 1 is -6. This is the position vector of PQ, right? As we know, PQ, this one is going to be the what? The same length and same direction, the same magnitude, and the direction with the vector PQ, right? You know, the same vector with the same magnitude and direction. Hence, the magnitude is the absolute value PQ equals square root of, right? 6 square plus -6 square, which you can find this one. This is 6 square root of 2. This is the magnitude. Yes, this is the magnitude. So what is the angle? For this one, let theta be its direction, right? Represents its direction. So the direction is found by theta, right? By its direction. And the point, the point, okay, which is the position vector, all right? So 6, -6 is in which quadrant?
The fourth.
Quadrant 4. Very good. So for quadrant 4, using our definition here, it can be a negative number, right? It can be a negative angle, yes? So we are just using what? Using theta is inverse tangent B over A. Okay, now for these two, the theta is going to be inverse tangent B over A plus pi. Okay, so here this one for this one. So definitely it's in the first quartile, so we can just take the inverse tangent. Hence, theta is simply the inverse tangent of -6 over 6, right? So equals what? Equals inverse tangent of -1. So what is this?
Three pi.
Negative 4 pi over 1 pi over 4.
Yeah, it's negative pi over 4. Okay, so it is going, it is the same terminal with what? With 7 pi over 4, right? It's the same terminal with 7 pi over 4. Okay, so theta is negative pi over 4. Okay, so that is the angle, right? That is the direction. Okay, so now let's draw this one, right? Let's draw this. Okay, say this is 5, -5, and 5, right? So -8, 1. So -8, 1 is somewhere here probably. All right, -2, -5. That should be somewhere here. So that is the vector. That is the vector, right? However, we got to firstly find the position vector, right? The position vector is 6, -6. So it's 6, -6. And then maybe somewhere here. All right, well, it should be what? Pointing to the same direction and also of the same length. Okay, so now for these ones, you got to firstly find the position vector of this vector. Position vector first, and then based on the position vector, based on what we have found here, all right, this one is different from these endpoints and these ones, right? So 6 and -6. Then based on this one, you find the magnitude and the direction. Okay, be careful on that. Okay, so this is this example. And
Is direction only -π/4? Could it not be 3 pi over 4? Or
it can, as we said, right?
oh, but
It can be what if it is in quadrant 4 or quadrant 1, that's inverse tangent. The range is -π/2 to pi over 2, right? If it is in the quadrant 2 or quadrant 3, then we
okay.
use this one. Okay. All right, consider this example. Nick?
Yes. Show that vector v with initial point at 5, -3, and terminal point at -1, 2 is equal to vector u with initial point at -1, -3, and terminal point at -7, 2. Draw the position vector on the same grid as v and u. Next, find the magnitude and direction of the position vector.
Okay, very good. Okay, so now let's do this one, right? Solution. V, all right, as the initial, and the position vector of V is, okay. So we can just define a V, right? So for the notation here, we also have, we can just find this one by the position vector is going to be this one, right? So we can just use this position vector. Okay, so PV equals, V equals, all right, so in the future, we can just write this one. The terminal is -1 minus 5 and 2 minus -3. equals what? -6 and 5. Yes. So similarly, u equals -7 minus -1, 2 minus -3 equals. All right, so this is -6 and 5. -6 and 5. Okay, so that's v and u. As we can see, they are the same. Hence, this implies that v equals u. They are the same, right? We show that they are the same. Now draw the position vector and the same grade as v and u, right? So next, make it the magnitude. All right, magnitude is, right, absolute v equals, all right, the position vector is the same, right? The position vector is equals square root of -6 square plus 5 square, that's root of 61. Okay, and theta, we have tangent theta equals 5 over -6, and theta is in what? Quadrant what?
Quotient 2.
Quadrant 2, because x is negative, y is positive, it's quadrant 2, right? Hence, theta equals what? We need a plus pi or we don't need? Do we need plus pi or not?
Yes.
Yes, right? So because as we see, it is in quadrant 2, right? So theta is plus pi.
What if it's in quadrant 3? Should it be 2 pi, right?
No, it's the same.
Same thing, right?
The same thing. Okay. Okay. Now let's see what do we have for this one. Can you please find this value? Anybody got it?
2.4469.
6.9. That is the direction. This is the magnitude, right? And I believe you can draw these vectors, right, in the plane, right? I'm not going to do that, but you can do that, right? So find these initial points and so on, right? So, okay. All right. Here we are going to introduce a very interesting operation of cloud vectors. It's a vector addition and difference. Okay. So if u is x1, x2, v is x2, y2, then their summation u plus v is going to be the corresponding summations of their coordinates. Their difference is here, their corresponding differences of their coordinates. Okay, now however, this summation and difference have some interesting geometric solutions here, interpretations here, all right, interpretations here. Okay, as you can see from their summation, is going to be what? U, V, and then their summation is going to be this same, this line. All right, it's going to be this line. Make sense? Okay, and their difference is going to be uv, all right? U minus v is going to be well, is going to be this one. Okay, so v is positive, so this one is negative v. Negative is from the other, the change their directions, right? This is already negative v, so it's going to be this one here. Now u minus v is the same as what? U plus negative v. Same as u plus negative v. Okay, so as you can see, if v is in this direction, negative v is going to be in the opposite direction, right? So u plus negative v is going to be from here to here. So they have some geometric interpretations as shown above. Make sense? Okay, let's consider examples. All right, Salim, can you read first, please?
Yes. Given u equal 3, -2, and v equal -1, 4, find their sum and difference, u plus v and u negative v.
Okay, very good. Okay, so let's consider this. All right. Now, difference, their summation firstly, u plus v equals 3 -2 plus -1 4 equals 3 plus -1 -2 plus 4. So this one equals what? 2 and 2. The difference u minus v equals 3 -2 minus -1 4 equals 3 minus -1 -2 minus 4 equals this is going to be 4 and this is going to be -6. Okay, so u plus v and u minus v. Now let's just draw these ones and see what we get. All right, so let's draw this one in plane. Okay, so 3 -2. All right, 3 -2. 3 -2 is somewhere here. This is going to be u. All right, v is -1 4. All right, so this is v. This is u. All right, so now let's just consider u plus v is 2 2. Okay, 3 probably here somewhere. 2 2, right? 2 2. Now let's complete this direction here. Complete this. Okay, so as you can see, this one, all right, u and this is a v. Now if this is a v, this is also v. Okay, this is also v, right? So u plus v is from u to this one, correct? Now another thing is if this is V, then, and this is V, right? So then negative V is going to be from what? Negative V. This is going to be, this is U, this is U minus V. So this is going to be U, right? This is going to be U minus V. V is going to be go this direction. So it is something like this. All right, so this one. Now from this point, which is 3, -2. And this is what? -1 and 4. Okay, so starting initial is 3, -2. Ending point is -4, -1, 4. Now this direction, this line, right? This line segments is what? It's the same as -1 minus 3, 4 minus -2, which is the same as what? -4. So sorry. -4. Okay, it should be what? Should be 4. Okay. U minus V. This is V minus U. Okay, so U plus -V. Okay, sorry. U plus -V. This one goes this one. So their difference, diameter error note. U is 3, -2. U minus V. Oh yeah, U minus V is going to be starting from here to here, or starting from here to this one. Okay. What is going to be U minus V? U minus V is from, this is U, this is U, starting from this one to -V this way. And it should be from here to here. How can I got something different? U minus V.
Your coordinates 3, -2, those are backwards. I believe it should be -2, 3
Oh,
on your graph.
on my graph. Oh yeah. Oh yes, that's right. So this is negative. Oh well. This is a. Oh, I made something. Some errors. Right. 3, -2. Okay, so I see. I see. Gosh, this is. Oh gosh, interesting. Okay, sorry about it. Thank you. All right, thank you. Very good. This is -1 and 4. Oh gosh, horrible. Okay, thank you. Okay, so it should be this, right? It should be this. So this is U and U minus V. All right, so it should be this from initial is at -1, 4, and ending is this, right? So that's going to be 3 minus -1, -2 minus 4. This, so which is 4, -6. So you got the same thing, right? So using this, what do you call this shape?
Would that be a parallelogram or something?
Parallelogram.
Is it? I'm not sure. I don't know.
I believe so. Parallelogram. Okay, there is a name for this shape, right? Like a square or the rectangle. This is a parallelogram. Okay.
It's a rhomboid, isn't it?
Rhombo.
I think. World War I tanks were made that shape. That's all I remember.
Okay. Now, yes, something, right? If their sides can be different, right? Two sides are parallel to each other. I believe that's the only requirement, right? The opposite sides are parallel to each other. I believe Mustafa is good with parallel green. Okay, it should be something like that. Okay, great. Okay, so scalar multiplication. We did vector summation and difference. Now let's consider scalar multiplication. Okay, so scalar multiplication involves the product of a vector and a scalar. Each component of the vector is multiplied by the same scalar. All right, so let's consider this figure here. V is given here. If you take 1/2, right, half the size. If you take the 3V is going to be triple. The direction is going to be the same, but the length, right, triple, right? 1/2 is a positive multiple of this vector V, so the direction is the same, but the length halved, right? Now, however, if you take the negative V, right, if you take the negative, the direction will change, right? Opposite direction, right? Initial becomes terminal, the terminal becomes initial, okay? So that's what we have for this. Make sense? All right, now let's consider this example. Joshua.
Given u equals 3, 1, and v equals -1, 3, 2, A, find 3u and -2v, and B, find 3u, -2v.
Very good. Thank you. All right. So let's consider this one. Quotient A. Now 3u as well as we know, right? It's just what? Multiplied by the scalar for each coordinate, right? So kx, ky. So for this one, we have what? 3 times 3, 3 times 1 equals what? 9, 3. Yes, this is 3y, 3u, -2v equals what? -2 times -1, right? And -2 times 2. This is +2 and -4. Right? So this is part A. We've got 3u and -2v. Now for B, we can easily see that 3u minus 2v is the same as 3u plus -2v. It's the same thing. So we already found this 3u is given here. 9, 3. -2v is 2, -4. So this one equals 9 plus 2, 3 plus -4, which equals 11, -1. Make sense? All right, which equals 11, -1. So this is by the what? By the scalar multiple and difference, right? And summation. Okay. Now, of course, we found 3u and -2v, right? We found 3u and -2v. Okay. So that's why we want to change this one as a summation, right? 3u plus -2v, because these are known, right? So we can just use the summation. Well, it looks like a what? A difference, yes? It looks like a difference, but it's better because in A, we already found 3u and -2v. So it's better to change it as the summation of one is positive, the other is negative, right? So I'm going to just plug in. Now, however, this is, we do not have to. So for instance, if I'm just directly, we can actually do, so for 3u minus 2v, right? So actually, we can just do the similar linear operation to each coordinate, and we can get the same answer. All right. So basically, what I mean is you got 3u, right? You can do 3 times u, x1, xu. So that's 3. Minus 2 times -1. All right, so do the similar linear combination for the x coordinate. Okay, and then same thing for the y coordinate. 3 times 1 minus 2 times what? 2. Now you can get what? 3 by 3, 9. 9 plus 2, that's 11. And then 3 minus 4, that's -1. Okay. The linearity of this combination, or you can just directly find this value. Okay, you can directly find this. Okay. Now, in other words, okay, do I have that? Not. Okay. For instance, if I want you to find something else, right? So -2u plus 3v, right? So can you find this one? -2u plus 3v. So using similar ones, right? So can you find this one? Equals what? Go ahead and see if you can find this. Okay. All right. Did you got this? Yes. Right. So you found that this -2u plus 3v is simply do the similar linear operation for each coordinate, right? -2 times 3 plus 3 times -1 plus -2 times 1 plus 3 times 2, right? So it's -9, 4. -9, 4. Okay. Now, of course, you may want to, okay, so like what we did in this example, you can firstly find what? -2u, right? You can find this one first. This is what? -2 times 3, -2 times 1, right? So equals what? -6, -2, right? And then you can find what? 3v equals what? 3 times -1, 3 times 2 equals -3, 6. And then their summation is going to be what? 2u plus 3v equals this plus this, as you can see, that's going to be -9. And -2 plus 6, that's 4, right? So you can do this one as well if you want to, right? So first the scalar multiple, and then take the summation. You got the same thing, right? You got the same thing. Okay, all right. I believe. All right, that's for today, and we're almost there. All right, so I don't think there are quite quite a lot of material left. Right, that's all. That's all. We tomorrow, right? Tomorrow on the 3rd, that's going to be what we're going to finish this all the lectures and then give a review for the final exam, right? And then if you have any questions, we will resolve any questions you may have about the final exam. If you do not have enough time, any more problems, we may stop a little earlier for tomorrow. Okay, so there will be a quiz. It's going to be the final quiz. All right, there is going to be a homework, and it's going to be the final homework. All right,
That's the last one.
so the last one. All right, so all right, that's all for today, and see you guys
Tomorrow.
Thank you.
bye.
Bye.